Let's continue our discussion on inverse functions. Let's study graphing the inverse functions. Suppose that two functions are inverses. If AB is a point on the graph of the original function, then the point BA must be a point on the graph of the inverse function. I have the graph of f of x and its inverse. Do you notice that the function and its inverse reflect over the line y equals x? The point 2, 4 is on the graph of my function. When I plug in 2 for x, my domain, 3 times 2 is 6 minus 2 is 4. I can also write this as f at 2 equals 4. Well, if 2, 4 is on the graph of my function, then the ordered pair 4, 2 is on the graph of my inverse function. When I plug in 4 for the x for the domain in my inverse, 4 plus 2 is 6, divided by 3 is 2. I can write this as f inverse of 4 equals 2. So f at 2 equals 4 means that f inverse of 4 is equal to 2. This is the function f of x is equal to x squared. I also know that this is a function because it does pass the vertical line test. And for every x, there is only one y. Let's talk about the inverse of x squared. I have now graphed y equals x squared and its inverse. Let's notice some points. I have the point 2, 4. Well, on the inverse, I have the point 4, 2. On y equals x squared, I have the point negative 1, 1. On the inverse, I have the point 1, negative 1. On x squared, I have the point negative 2, 4. On the inverse, I have the point 4, negative 2. Do you notice that the inverse graph of x squared is not a function? It does not pass the vertical line test. I could restrict the values of the domain on my function f of x is equal to x squared. I could say let's only use those x's that are greater than or equal to 0. My graph will now look like this. So let's study this part of my function and its inverse. Here is my function with a restricted domain and its inverse, which is now also a function because it does now pass the vertical line test. Notice that the function and its inverse do reflect over the line y equals x. We do have the point 3, 9 on my function, and we have the point 9, 3 on the inverse of that function. The ordered pair 3, 9 can be written as f at 3 equals 9, and the ordered pair 9, 3 that is on the inverse of that function can be written as f inverse of 9 is equal to 3. Good luck continuing to learn about functions and their inverses.